All right, guys, we're going to start chapter 1 with section 1 called variables and expressions. So previously you performed operations on integers, and now you're going to write verbal expressions for algebraic expressions and write algebraic expressions for verbal expressions. So just some vocabulary before we get started. Algebraic expression, variable, term, factor, product, power, exponent, and base. And we'll talk about those as they come up. So an algebraic expression consists of sums and or products of numbers and variables. In the algebraic expression 10D, the letter D is called a variable. In algebra, variables are symbols used to represent unspecified numbers or values. And in general, variables are going to be letters, and any letter can be used as a variable. But sometimes we don't use I very much. And there's some other letters just because they're kind of tricky and it can be easily look like a number instead of a letter and be confusing. But anyway, so these are examples of expressions. So you have 10D, 2x plus 4, 3 plus z over 6, p times q, 4cd divided by 3mn. A term of an expression may be a number, a variable, or the product or quotient of numbers and variables. For example, 10D, 2x, and 4 are each terms. Typically, terms are separated by addition or subtraction. Now, if you just have one term like this right here, the 10D, then that's just one term. But the 2x plus 4, you have two terms here. The p times q would not be two separate terms because they're not separated by addition or subtraction, and same thing here. Division does not separate terms. Okay, so 2x plus 4, let's take a peek at this. The term that contains the x or other letters is sometimes referred to the variable term because it has a variable in it, and the term that does not have a variable is called a constant term. Now, constants are kind of the opposite of variables. Variable, if you think of the word variable, it means something that could change. Well, 2x would change depending on whatever value x represented. But 4, that part of it is going to remain constant because 4 is 4 no matter what. If you have 4 pencils, you have 4 pencils. Not going to change unless you take pencils away or add more to it. So in a multiplication expression, the quantities being multiplied are factors. So for example, in the p times q, p is a factor and q is a factor, and the result is a product. So think of product as being the answer to a multiplication problem. A raised dot, like in the p dot q right here, or parentheses are often used to indicate a product. And here's several ways to represent the product of x and y. You could have x, y smack up against each other, x times y with the dot in between, xy with the parentheses around the y or around the x or around the x and y. All of those represent x times y. An expression like x to the n is called a power. The word power can also refer to the exponent. The exponent indicates the number of times the base is used as a factor. In an expression of the form x to the n, the base is x. In the expression x to the n, the x to the nth power. When no exponent is shown, is understood to be 1. So x is the base, n is the power. The power tells you, it's shorthand for repeated multiplication. So x to the n tells you how many factors of the x to multiply together. The x is the base. And if there is no exponent, it's understood to be 1. So the base is x and the exponent is n. So example 1, write a verbal expression for each algebraic expression. 3x to the 4th and 2z squared plus 16. So how are we going to do this? So for letter A, that would be 3 times x to the 4th power, because 3x, 3 with the smack up against the x right there, means 3 times x. This is 5 times z to the 2nd power plus 16. Here's a couple for you to try. Go ahead and pause the video, and when you're ready, hit play. All right, we're back. So what did you get? The first one is 16 times u to the third power, no, second power minus 3. Okay. The second one is 1/2 of a plus the quotient of 6 times b and 7. Okay, now if yours wasn't word for word exactly the way I wrote it out, it could still be correct. There's not a single correct way to write the verbal expression for these algebraic expressions. Alrighty? All right, well, that's it for this video. Stay tuned for the second half of this section where we are going to talk about writing algebraic expressions. See you there.